So let's try to use this wonderful tool that Bruno Bienfait and Peter Erti have come up with. It's a free chemical molecule drawing package, and it has all sorts of things here. So we will try to essentially draw an alkane and then go from there and add some functional groups from there. All right, so I'm going to draw a pentane. Pentane is, I can draw it either from this one thing or this squiggly thing here. So here it is. So now I have one carbon here, one carbon there. If I keep adding, and so I have 1, 2, 3, 4, 5. Pentane is this molecule. All right, it's that simple. So now I want to make it a pentanol, that is the alcohol. Since it doesn't say anything other than pentanol, it is assumed that the alcohol group or the hydroxide group is going to be on the N carbon. So it's going to be either this end or this end. All right, right now, if I just do this, it adds a link, and now I can actually tell it, well, here it's not a carbon, it's actually a OH. So now I've got 1, 2, 3, 4, 5, all. So that's a pentanol. Okay? So now I'm going to draw a pentanal. So I just remove this. Okay? So now 1, 2, 3, 4, 5, same. And I'm going to make pentanal. Pentanal is an aldehyde, and it has a C double bond to oxygen and a single bond to hydrogen. So I'm going to do a double bond here, and I'm going to put it over here, okay? And I will add oxygen. Technically, this is enough. But, you know, we kind of like, we don't see the H here, so it's a little possibly confusing. So let's add an H. So I'm just going to add another bond here. I'm going to tell it's an H. So if I look here, carbon, nitrogen, oxygen, I don't see any H, but there's an X here. It turns out that the X can be any atom, really, and by default it's H. So I'm just going to use X over here, and there we go. We now have 1, 2, 3, 4, 5. So it's a pentane, and now it's an aldehyde group, so it's pentanal. Okay. All right. So I'm going to remove this group and this as well. And now I'm going to create pentanon, so the ketone. Well, the ketone has to be on one of the, it can't be at the end anymore. It has to be on one of the inside carbons. So it could be, you know, if I put it over here, it's going to be a that's a pentane. Carbon number 1, number 2, number 3 is going to be pentane 3 on. All right, well, okay, sure. Well, it doesn't really matter for us. Right now, I really want to be able to show the functional groups. All right, so I'm going to remove the ketone over here, and then I'm going to create a pentanoic acid. So the pentanoic acid is the acid based on pentane. Well, it's very simple as well. You know, we know it's a double bond here, and it's a single, so double bond for the carbonyl group here, and a single bond for the hydroxide group. So here we are. That's 1, 2, 3, 4, 5, still 5 carbon. I haven't changed anything, so it's pentane, and now since it's a carboxyl group here, then it's pentanoic acid. All right, and now I'm going to remove that, and I'm going to make a pentanamine. Pentanamine is that at the end of the carbon here, there's an amine group, and now you understand it. I just add this, and I say, okay, it's going to be an amine group. There we go. It's a pentanamine group. And that means we're saying that the amine is added to the pentane, but sometimes the amine becomes centric, so we actually say it's a pentyl amine. It works the same. It's the same idea. So I'm going to remove this again, and I'm going to create a pentane thiol. Well, pentane thiol is just the same thing. I just add this bond, and at the end of this bond as a, by the way, it's a thiol and not a it's a it's a sulfonyl, and therefore now the CSH here becomes a thiol. So that concludes just this this small tutorial on how to use JSME for very simple alkane-based molecules.